Okay, so last time with linear programming, we dealt with this problem. I want to continue with this problem right here. Just to review the steps, we had these 4 lines here. Y is less than or equal to 6, y is greater than or equal to 3, y is less than or equal to 3x plus 12, and y is less than or equal to negative 2x plus 6. And then we graph them, okay? I graphed them on Desmos, but we should be familiar with how to graph these paper and pencil as well. Okay, so this is good practice for you guys to practice graphing lines and shading. Okay, and if you notice my 4 lines, they create a shaded region. We talked about this is called the feasible region right here. And we come up with 4 points, 4 vertices for that object right in here, this trapezoid that ends up being our feasible region. Okay, that's all we did last time. Now we're going to go a little further with it. So what we're going to do is we're going to plug those 4 points into our table here, and then we're going to plug them into our equation. Okay, this equation that they got, 4x minus 2y. We're going to plug x and y each time into this equation. So it's going to be 4 times negative 2 minus 2 times 6, and that's going to give us a value. So that's negative 8 minus 12 is negative 20. Then we're going to plug in 0 and 6. 4 times 0 minus 2 times 6. 4 times 0 is 0. Minus 2 times 6 is negative 12. So 0 minus 12 is negative 12. Again, we're using this equation right here, and the points we're using are the points that we found on our graph, the vertices. Okay, now I plug in the negative 3, 3, negative 12, minus 6 is negative 18. And the last one was 1.5 comma 3. You can't just guess that that's 1.5. You got to do a little bit of algebra to figure out, is that exactly halfway? Okay, we can go through that another time through a Google Meet or something like that. So 4 times 1.5 is 6, and then 2 times 3 is 6, so 6 minus 6 is 0. Okay, so now we're going to find our max and our min. The highest number value here is actually 0. So this is our max right here. That's our max. Now the lowest number is negative 20, so that's our min. So that's basically the answer. The max is 1.5 comma 3, and we get 0. And our min is negative 2, 6, and we get negative 20. Why are we doing this? The reason why we're doing this is like a real world situation here. Okay, if you're a business, you want to know how many action figures do I have to sell to make a profit? How many hamburgers do I have to sell before I can make a profit? Then maybe you may end up making too many hamburgers where the hamburgers go to waste, and then you're going to lose some profits. So what's the maximum number? If I make 100 hamburgers a day, that's the most money I'm going to make. If I make 101, if I make 101 hamburgers, I might actually lose money, okay, because I'm not selling as many hamburgers as I thought I would. Okay, so that's some vocab there for you, and this is a very common thing used in the real world. So now, in school learners, you guys are going to work on some more problems tomorrow, and distant learners, this is going to be the problem that I want you to work on tomorrow as your classwork assignment. Okay, so I want you to graph these 3 lines here, 1, 2, 3. I'd like you to try to do it on graph paper instead of using Desmos. Okay, find your feasible region, find your vertices, and plug them into the 9x minus 6y, and get your max and min. Of course, ask me questions if you have them, email them to me. I hope you have a good day.